Every digital lock protecting human civilization is about to melt away. Right now, the entire global economy relies on public key cryptography standards like RSA 2048 and elliptic curve systems. These algorithms protect everything from your mobile banking app and corporate clouds to top-secret defense communications and national power grids. They work because a classical supercomputer would need roughly 300 trillion years to crack their underlying mathematical code. But a new physics paradigm is approaching. A cryptographically relevant quantum computer, utilizing the laws of superposition and Shor's algorithm, will be able to dismantle that exact same encryption in less than 24 hours. In cybersecurity, this fast-approaching structural collapse has a definitive name: Q-Day. While early predictions placed Q-Day safely in the mid-2030s, recent breakthroughs in error-corrected logical qubits have radically accelerated the threat timeline. Leading technology groups like Google and global defense agencies are now actively racing against a compressed target window of 2029 to 2030. The crisis, however, is not a future event. It is happening in the present tense through a strategy known as HNDL, Harvest Now, Decrypt Later. Sophisticated threat actors and hostile intelligence agencies are already intercepting and archiving massive amounts of heavily encrypted corporate and government data today. They do not need to read it now. They are simply stockpiling it in giant data centers, waiting for the exact hour Q-Day arrives to decrypt decades of human history in an instant. To counter this existential threat, the tech industry is pivoting toward post-quantum cryptography, or PQC. The financial reallocation backing this shift is monumental. The global post-quantum cryptography market was valued at $438 million in 2025 and is projected to skyrocket to over $19.2 billion by 2035, compounding at an explosive annual growth rate of 46%. This rapid scaling is enforced by severe regulatory mandates. Following the official finalization of NIST's first post-quantum standards, like FIPS 203 and 204, governments are no longer making compliance optional. For example, national security policies now dictate that all critical infrastructure, software signing certificates, and hardware routers must support hybrid post-quantum algorithms by 2026 to 2030. The dominant shield in this architecture is lattice-based cryptography, which currently captures over 50% of the entire PQC market. Lattice-based systems conceal data within multidimensional geometric structures containing thousands of hidden coordinates, a math puzzle so incredibly complex that it completely neutralizes both classical supercomputers and quantum particle systems. Migrating a large enterprise or a global banking infrastructure to these new protocols is an incredibly complex engineering task, costing large organizations between $10 million and $50 million and taking up to 54 months to properly complete. Organizations that delay their cryptographic inventory are already mathematically out of time. The clock is ticking, and the second hand is accelerating. We are in a flat-out sprint to rewrite the security architecture of the internet before the quantum era breaks it open.